we begin, does anyone have any questions about what we covered last time? Any like random questions you got before you went to sleep?
So here's my random question. Oh.
In the chat.
Yeah.
Sorry. Wait, can you tell me your name actually? Because I do want to know your name. It's just Dangerkin.
Oh, it's Will.
All right, sorry, Will. So I put some questions in the chat, so if you can answer them later, that'd be great.
Yeah.
Yeah, we'll answer those during the town hall thing.
Okay, so this might sound really weird, and it makes it sound like I didn't understand anything, but what exactly is torque? Like, no, I understand, like, how to find it, like, I understand that, but, like, what is torque just in general? Like, as, like, a force? Like, or not as a force? Like,
it's rotational movement.
So the way I would think about, like, do you understand what, like, a force is, right? A force is just anything that causes motion. So, like, if I move this here, I'm applying some force to move it.
Yeah.
You like, is that okay with you?
Yeah, that makes sense.
Okay, so torque is that same principle just applied for rotational motion.
Oh. Okay.
So when I'm talking about forces, I'm meaning just like linearly, like it's moving this much horizontally and this much like vertically. When I'm talking about torque, we're talking about like if I had a circle, like it's going to be moving in a circle, and its force are going to make sure that it constantly moves in that like in that circle.
Okay, got it.
Does that like make a little more sense?
Yeah.
Like once you take physics, like you'll definitely have like a little bit of a better understanding right now, because it's a little weird to understand without some physics background. But yeah.
Okay, thanks.
Think about it. Okay. Any other questions, thoughts, concerns? Okay. So when we use motors, it has an output shaft. So this is this thing that like spins as a direct result of like the motor working, this shaft right here. So this is what we call the output shaft. The ones that we use in FRC are all going to be 8 millimeter. So on this VersaPlanetary, on this Redline motor, you can see it has a coupler on right now, but like you can see this is the shaft. It's 8 millimeters. It's really small, and by itself, it's not really useful. So that's where we have to change what we call the output geometry. The first step in doing that is you'll see that like the Sim and Neos, they have this like space in here. This is for the key. So this is what we call like a key. And when we attach our output shaft to like then like a gearbox or just like the next stage in like in a motor gearbox process, right? It needs this key, because if you think about it, two like circles, like I don't have two concentric circles, but if you have two concentric circles, right, and the first one is spinning, that doesn't do anything for the second one. So this key ensures that the inner circle, like the inner shaft's rotation is transferred to like the outer shaft. All right, so does that make sense?
Yeah.
So when we change output geometry, there's several things that we can change it to. What we usually use and what you guys have used in your designs is going to be 1/2 inch thunder hex. So let's just go here. So this is just like a Vex website. If you guys ever are bored, you guys can like scroll these websites too. But so we have, this is hex shaft. So it's called hex because, you know, it's hexagonal. This is pretty, in the real world, they don't use this that much, but it's very, very common in FRC. Then there's round shaft. So as its name implies, it's literally just like a circle. And the difference between like 1/2 inch and like 3/8 like hex is literally just the diameter from, you know, tip to tip. You will not see 3/8 inch generally in FRC. In other robot competitions, you might, but you'll generally see 1/2 inch diameter. What we use here is Thunderhex, which is like Vex's like own special product. As you can, I don't know if you guys can tell from this image, but like unlike normal like hex, which is just like a perfect hexagon, Thunderhex has like these rounded edges. So what that means is you can use Thunderhex for both circular bearings and hex bearings. So actually, let's just show you guys. Did your computer randomly just like switch to like Yahoo, like the Bing search engine?
I think you just have Bing as your search engine, Bhaskar.
No, I don't though. I always change it.
I think it's because like the safe search.
Yeah, I think that might be it, but I thought I turned that off. Like, I'm 17 years old now. I'm too cool. Anyways, so yeah, like this is a circular bearing, and then we have, a hex bearing. Just the differences for like different shaft. So the cool thing about Thunderhex is because it has these rounded edges, it can work in both hex and circular. So we generally use Thunderhex, and the other benefit from using Thunderhex is that it has this hollow center. So then that means we can thread it. And threading is a concept we'll go over a little later, but that's just one of the benefits that we'll talk about. So yeah, what we use, like, in addition to like changing the torque and angular speed, these gearboxes are also really good for changing output geometry. Because like I said, these 8mm shafts aren't super useful on their own when everything else is like half-inch hex or something like that. Oh yeah, and for all the variations that I showed you, like hex. Oops. Yeah. Okay. So for all the variations that I showed you, there's like there's a female output shaft, which is this basically like, this is like the, I guess the male version you could call it. There's just a female version for it, and we use those pretty frequently too. Yeah, so any questions or thoughts about output geometry? Those are the different types that FRC, like that are FRC legal. In general, we will be sticking to 1/2 inch Thunderhex.
How do like the female and the other like types of shafts interact with each other? Like, why is there a separate like female shaft?
So like if this is the male output shaft, right? So like let's say I have a shaft, right? That's like 1/2 inch Thunderhex, and I want to connect it to a motor. I would put a female end attached to the motor so that the shaft couples with like the female end. So it's just like you're just inserting the shaft into the female output part. Does that make sense?
Okay, yeah, I think I get it.
Yeah. Not being too weird about it. Yeah. So any other questions about that? This is pretty important because like up until now we've just been saying that we're motor to a shaft, but like this doesn't just connect to the shaft by itself. It has a little bit of engineering, I guess, to it. So then now we're going to talk a little bit about how VP works. So okay. So like this is an example of like a male output shaft, right? This is like looks like 1/2 inch Thunderhex. This is what it would look like attached to the gearbox. I just showed you one. Like this would be another example of just like 1/2 inch Thunderhex. So the way a VP works, the way you attach it to a motor is the first step is you need like this mounting plate. So let's say I have this VP, right? The first step I would need is to attach a mounting plate to it, which I have like right here. So you attach that via screws, and that mounting plate allows you to attach like the rest of the gearbox to it. So the first stage over here, so like this one, a better picture of it. Yeah, so like this one, this was the one that couples like this 8mm shaft to like the rest of the gearbox. So this is called like the base stage. It's pretty big and hefty. So you take your motor out, your motor mounting plate, and you attach it to your base stage, and then on the base stage, everything else gets to be attached. So like in this example above, you know, you see that it has like one reduction stage. So you can have up to 3. 3 in general is like your stopping point, because like we said, theoretically you can have, you know, as many reductions as you want, but like there's physical constraints in the motor. And then after the reduction stage, you attach, you know, your outputs. So if it was like a female output shaft, just like Thunder Hex, whatever it is. Does that make a little more sense about how gearboxes work? Okay. And then once we have, you know, our motor and gearbox working in tip-top shape, we have to transfer that rotation somehow. So this should be like a bit of a review because we already talked about this, but I just wanted to put it in words. Chain is pretty effective. We use it really frequently because it's versatile. I mean, it's like really mobile, so you can like change the dimensions pretty easily. We'll go over some of this when we go in person. I just wanted to write it down. Yeah, there's not much to chain. If you guys are really interested in like the actual names, here it is. This is like a final call for, I guess, chain questions or anything else. Yeah, and then we have plate sprockets. So this is what like, I don't know if we touched on this last time, but basically plate sprockets are really large sprockets that we attach directly to like arms and stuff. So like if you go back to our Luna example, where was it? Okay. Like this right here is your plate sprocket because it's attached directly on the shaft that your arm is rotating on, and it has like a huge teeth count. There's not much to plate sprockets besides you generally use them for rotating your arms. And like this one, for example, has like a 72 teeth count. Like normally your sprockets that you're going to use are like 22 teeth-ish. But yeah.
Yeah, if you guys remember, we talked about it earlier in the summer before we did hex hubs. Because I remember to our knowledge, or like I think we just kind of forgot about hex hubs, but you attach the plate sprockets onto the VersaBlock itself, right? And then that lets you like rotate an arm if you chain it with something else. If you guys remember that, I can try to find you guys a better picture if you're a little unsure. But yeah, we talked a little bit about it if you guys remember.
Yeah. So any questions about that? That's just letting you guys know that's there, because if you guys ever have, you know, kind of a heavier arm, definitely go in the direction of a plate sprocket. That's definitely the way you want to go. So yeah, any questions about that? Giannis will find you a link, hopefully, a little later. Okay, and then we have belts. So in general, belts are like quieter and sleeker than chain, and they're better over time because they won't stretch after like the initial bit of use. But the cons of just having a really like having the belt in place is that you need very specific measurements, like for a drive base, for example. Sorry, the link didn't work. Did I just mistype something? Bro. Alright. For the drive base, what the heck?
It's 14U4.
Oh, did I type in 14 again? Might be. Thanks, Matt. So for the drive base, right? When you attach belts to it, what the heck? What is this? What is this? So when we attach belts to the drive base, right? These measurements are super specific. So like when they machine these are very specific measurements. So when you attach a belt to them, it's like not a problem because they already have figured everything out. But for our purposes, like when we're going to design like a robot or something that's like completely new, like one of our mechanisms, we're very likely not going to be able to get that precision. That's why we're not going to use belts for like for that type of stuff. We will use belts if you guys remember to talk like when we talked about dead zones. We will use belts when we're moving stuff inside the robot so that we don't have any more dead zones. But yeah. Any questions about belts and stuff? Oh yeah, and it can also be like used to replace a roller, like I said, for dead zones. And a roller is literally just like what you would imagine. Just a roller. And then also this should be another quick review. Spacers and shaft collars are just the two ways you would like attach something to what's it called? To retain stuff like on a shaft. So spacers is what they would look like. You can make these as long as you want. And then shaft collars is also you guys know what this looks like. It's retained on the shaft. There is like a third type, which is bolt and washer. And I generally want to talk about tapping before we go into that. Okay. That's all I had for today. It was just like a quick finalizing of like gearbox and some rotation stuff. Do you guys have any questions about what I just talked about? Yeah, you're good.